Do you know why most refactoring attempts fail? You refactor your code and hundreds of tests go red. But you know that your system is still correct. You didn't change its behavior at all. And this, my friends, is when developers start to not trust automated tests. And it all happens due to structure-sensitive tests. The premise here is that the refactoring should not break your tests. Let me show you an example when that tends to happen. This is a simple test class. I have 3 test cases. Basically, I'm checking on the order discount calculator. If I'm sending an order with a regular client, I should have 5% discount. If I'm using a premium client and the total of that order is under 1,000, it should return 10%. If it's above the 1,000 and is a premium client, then it should be a 12% discount. If we look into the source code that is implementing that calculator, what you can see here is a simple logic that will return 5% for everyone unless it's a premium client. And when it's a premium client, is delegating the responsibility of calculating that to a different class that is under this interface. This is quite common, taking the decision of putting concerns in a different place even before it's proven that you need that refactoring. So this is a common case that you will see everywhere. And on this case, if I run all the tests, you will see that they succeed. So everything looks fine. I'm confident on my tests, at least I should be. But in fact, there's a major problem here. If I look into my tests and I read the description, what I expect is that, okay, I'm just providing information into that calculator and I'm looking into the output, right? So any single refactoring inside of that calculator should not break these tests. As an example, let's go to our order discount calculator. As a developer, I'm looking into this premium client discount, and I think that in fact it doesn't bring the value that I was expecting. Okay, I was expecting this to be much more complex than in the reality it is. So I believe that moving this inside of the calculator would even make more sense because now I have there all the rules. Let's say that this is the type of refactoring that I could eventually do. So I would copy this thing and replace here. Simply replace this value with the order.total. And okay, this seems like a simple refactoring to do. Now that I've changed that, in theory, all my tests should go green once again. So let's run them once again. But as you can see, I have some tests failing. Why? I know that my system is behaving the same way. The only thing that I could have done in this refactoring was doing a bad copy-paste, let's face it. So why this is failing? Tests should not fail because I changed the structure. In fact, they should only fail if I change the behavior. And this is the moment when usually developers start to not believe on their tests. Okay, they start losing confidence on the tests. But why this is happening? You may have noticed that I'm receiving here an interface. This is a common problem in tests, that is, we are testing this class, this calculator, so we think that maybe we should put other objects behind an interface just for the sake of testing so we can mock it. And that will lead to this structure-sensitive test that we are looking at right now. So if we open the test, we will find things like this, where we are defining a mock, setting up what should return, and then, for example, verifying that it has been invoked. So, in fact, what I was doing is checking the flow of the code through my tests. Those types of tests usually don't resist too much to refactorings. So let's remove this thing and fix this test. I will go to my calculator, remove this thing from here, remove from here, remove the constructor, save it, go to the test once again, clean up this mocking thing, remove from the constructor, remove the verify, do the same to the other tests, and run my tests again. This time they succeed. Now you may ask, what if in our calculator we in fact want to use a different class to be the home of this logic? Let's say that this grow and will be more complex than this, and we want to keep it on a different place. You may decide to move this to a private method. You may decide to move it to a different class. I will show you the case using the class. So on this case, what I will be doing is that I will define here my premium discount calculator that I was using before, and I will call it from here. As you can see, I'm simply instantiating that instance inside of this class. In fact, I will go to that class and I will make it internal. I have no need to exposing this thing to the outside world. Now let's run the tests again. Let's see, and they are still green. That's the good news. So we finally changed that code due to a refactoring, and we didn't break the tests. That means that now this code is structure insensitive. Every time that you are testing the things that go under the hood, or you are exposing things just for the sake of testing, you are exposing a lot of interfaces just for the sake of mocking, usually you will lead to tests that are structure sensitive. Structure insensitive tests is one of the properties of a good test. Readability is another one. That's why you may want to take a look into this video. I will see you soon, and in the meanwhile, just keep things simple.